All right, this is a video for Algebra 2 in our unit on trig functions. We're looking at translating sine and cosine functions. Translating means moving those functions in the vertical dimension, the horizontal dimension, or maybe a combination. So I want to show you these two types of translations. Hope you can see that we can take that red wave and shift it to the right a certain amount, and it'll match up with the blue wave. Similarly, we can take the red wave over here, move it up a certain amount, it would match up with the blue wave. So those are examples of translations. Let's do a couple examples involving phase shifts. So in other words, moving in the left-right dimension. Those are always a little bit harder. And then we'll address the vertical translations just through some solved examples. This first one right here is an example of a rightward shift by 2. In other words, if we started with the function f of x, we graphed it up, and then we thought about graphing the function f of the quantity x minus 2, which we would then call g of x, that new function would be moved to the right by 2. Okay? That's a little bit counterintuitive because that's a subtraction sign right there, but it's just something that you need to remember. Somehow you need to memorize that when we're subtracting a positive number from the x inside the function notation or before the function has been applied, that's a rightward shift. And separately, for this next one, when we're adding a positive number or subtracting a negative number, that would be an example of a leftward shift by 4. Okay, just for example there. So let's go ahead and do some actual graphing of some sine waves and cosine waves and such. So I have, it looks like we have two graphs we're being asked to graph here, two functions. I have the core parent function, parent sine wave, graphed already to kind of help me out. I really suggest doing that ahead of time or as part of your work. It's hard sometimes to graph these without graphing the parent function first. This is a vertical shift. This y equals sine of x plus 3 is a vertical shift by 3. So you can simply think of each of these points as being moved up 3. Okay. Everything else, every other aspect of the wave stays the same. We just have moved the wave up 3 units. Next, we're going to work with a right shift of pi over 2. Okay. And same deal, we can take each of my key points and move them to the right by pi over 2. And then I sketch in as much of my wave as I have in that situation. And then I think you can tell that we need to backfill a little bit, so we are graphing a full cycle of the wave. And we would fill in that last point right there. All right, let's do a little bit more of a complex one. We have y equals the sine of the quantity x plus pi minus 2. So this is a left shift of pi, and this is a downward shift of 2. Okay, so let's apply each of these points. And I'm going to try to do them both at the same time. And the other thing that I think is helpful here is as I'm plotting my new points, keep in mind this is, for example, a downward slope. This is, for example, an upward slope. So I sketch that in a little bit as well as I'm plotting my new point. Sometimes it can get confusing which part of the wave we're plotting. So let's plot this point first. We have to take it and shift it left pi and down 2. So it ends up over there. And again, I want to remind myself it's a downward slope. Let's take this point right here. It's an upward slope. Shift left pi and down 2. And I get that point right here. And reminder, it's an upward slope. This point here, this trough, this valley, we're going to shift it left pi and down 2. And I have that point right here. And I just remind myself it's a valley. And then we can just continue the pattern from there. Okay, so I'm going to sketch in a smooth curve. And then continue the pattern. Okay, so it looks like that purple wave is a solid graph of that function we were being asked to graph. Just as a quick summary, this is really a compilation of what we've been looking at so far in terms of sine and cosine waves, and then also some of this new stuff with translations. So A is equal, the absolute value of A is equal to the amplitude. And then separately, if A is less than 0, we have a vertical flip happening. So a flip across the x-axis. B, I want you to recall, is the number of cycles of the wave in the space of 2 pi, meaning that 2 pi over b is a little mini formula, a little mini equation you can use to find the period of the wave, or the wavelength. H is just a left-right shift. And if h is greater than 0, we'll shift right. And again, the thing to keep in mind, here we are subtracting h up top, okay? So if we're subtracting a positive number, if h is greater than 0, we'll shift right. Often it's easiest just to show an example. If we have x minus pi over 2, this is a right shift of pi over 2. So you just need to remember that. And then k is the vertical shift, the vertical in the vertical direction, and it's intuitive. If k is greater than 0, we have an upward shift happening. Okay, so that's a summary of sort of complete standard form. And also, please do keep in mind that this all applies for cosine as well. We just happen to have sine written out, but it applies to cosine as well. All right, let's do a graph y equals the sine of 2 times the quantity x minus pi over 3, all shifted down by 1.5. This has a lot going on with it. And probably the most complicated piece of it is pi over 3, which doesn't fit cleanly into my scale that I have. But we will do our best. I am definitely going to graph just a normal sine wave first, so a parent function sine wave first. And I'm going to try to take advantage of something. Whoops, I missed some points, but I got it correct when I did it correctly when I graphed the wave. I missed some points initially. Okay. Let's see if this works on my app here. I want to try to see if I can just move this down. Is it going to work? Okay, so we're going to move it down by 1.5. Okay, so let's look what we've done so far. We've taken care of a sine, and we've taken care of the minus 1.5. Okay. Now, next what I want to do is take care of the rightward shift by pi over 3. Okay, and then I'll deal with the cosine, or with the adjusted period. Actually, let's deal with the adjusted period first. So I think we can tell that the period has to be 2 pi over 2, which is simply pi. Okay, so I am going to try to deal with that next. Let's see here. There's a lot going on, and this is a little bit complicated. I want to take a step back first and actually draw my midline. So this is down. Here's my midline of down 1.5. Okay. So I probably should have shifted this down a little bit further to reach that midline. Okay. Now we can deal with the fact that we have a period of 2. So let's do this in red now, or a period of pi. So we start there, we return there. That's our halfway point. And looks like we've dealt with that. So now we've dealt with the fact that it's a sine wave. We've dealt with the reduced wavelength. We've dealt with a downward shift. We have to deal with a rightward shift now of pi over 3. So pi over 3 is, let's see, is roughly roughly on my x scale that amount right there. So let's take each of my 5 key points on my red curve and just shift them to the right by that amount, and my new curve I will have in blue. A little less than 3 squares, something like that. So my new wave is going to look something like that, and I can continue it in the leftward direction as well. So the blue wave is a reasonably good graph of what we were being asked to graph right there. And as a last quick practice problem, what we'll look at is just write some equations as opposed to creating graphs. So we want to write an equation that models a transformation of a sine function shifted up by 3. Hopefully this seems pretty straightforward to you. We're just going to take our sine wave and just add on 3 at the end, and that'll move my whole function up 3. We want a cosine function next that's flipped vertically. So that's a negative cosine. And then we have a leftward shift by pi over 2. So I throw in an h value of negative pi over 2, keeping in mind that let's always have that at least start off being a subtraction symbol. So this is a negative cosine of the quantity x plus pi over 2. And that would be my final answer for that one. So shifting sine and cosine waves, translating those waves. We got through it, and that's a good place to stop.